The world population is now 8 billion people, an unprecedented speed of industrial and urban development, and the COVID-19 pandemic propels a thirst for energy. The whole world is facing a wave of energy crises. The picture of the future will continue to look gloomy if we persist in running the world the old way. But currently, many countries have begun transitioning towards a greener, cleaner, and more sustainable future by implementing plans to shift towards renewable energy sources. How far have renewable energy technologies developed? How do we promote a quicker energy transition? What are some affordable and clean energy solutions? We will have these answers and more in today's panel session on the future of energy.
Ladies and gentlemen, welcome to the inaugural Science for Life Symposium. It's so nice to see everybody offline and online today. The symposium will create connections between Vietnamese sci-tech community and top scientists. The all-day symposium will have 3 consecutive 90-minute panels, each focusing on one critical issue for the future of energy, future of artificial intelligence, and the future of global health. The panel will focus on global issues, upcoming trends, and projections of key changes in people's lives. We'd like to extend a very warm welcome to our distinguished guests, speakers, and VIPs. Mr. Bùi Thế Duy, Deputy Minister of Science and Technology. Mr. Đặng Bằng Việt, Deputy Head of Science, Technology, and Environment Department, Vietnam Electricity. Mr. Võ Quang Huệ, Deputy General Director of Vingroup. Mr. Trương Quốc Hùng Stephen, CEO of VinBrain. And Dr. Lê Mai Lan, Vice Chairwoman of Vingroup, CEO of VinFuture Foundation. Ladies and gentlemen, it's our honor to begin the symposium today with the first panel discussion, The Future of Energy. VinFuture Prize is a global, reputable sci-tech prize. Discussion points at the panel are critical for global scientific advancements and supporting people's lives. Vietnam is a committed nation who plays an increasing role in contributing to world's technological development. To begin our event today, we'd like to invite Mr. Bùi Thế Duy, Deputy Minister of Science and Technology, to the stage for his speech. Vâng ạ, xin trân trọng kính mời Thứ trưởng Bộ Khoa học và Công nghệ ông Bùi Thế Duy lên sân khấu cho đôi lời phát biểu mở đầu chương trình ạ. Xin mời ông.
Okay. Morning, ladies and gentlemen. Welcome all of you to Vietnam and to Vingroup today. And welcome all the scientists from Vietnam, especially to the 3 symposium, very important and very interesting symposium on the future of energy, future of artificial intelligence, and the future of the healthcare as well. So on behalf of Ministry of Science and Technologies, we would like to congratulate Vingroup on organizing these events, especially on the occasions of the VinFuture Prize. And I think this event will really encourage the whole science and technology communities of Vietnam, especially for the young scientists of Vietnam. And we're very happy that you have selected the 3 very important and very interesting topics. That is the energy, the AI, the digital technologies, and the healthcare. And that exactly is solving on the problems of Vietnam right now. So in Vietnam right now, we are facing the problems of climate change and the disease pandemics like COVID. And we have to use a lot of technology to solve the problem, especially digital technologies with big data, with artificial intelligence and other related technology as well. And we would like to thank Ving Group to bring all the best scientists among the ones to be in the committee for the prize, as well as to organize the 3 symposiums today. And we hope that this symposium will create a great connection between Vietnamese science and technology communities with all the top leading scientists all over the world, as well as this symposium will create a new wave of investments into the science and technology, not only from the government, but also from the industry as well. So I hope that we will have a very interesting discussion today, and we bring a lot of new ideas, a lot of new solutions to solve not only Vietnamese problems, but also the problem of the whole world, of the climate change, of the pandemics, and we look forward for the very bright futures. So hope that with the future of energy, future of AI, and future of healthcare. Thank you very much.
Thank you, Deputy Minister, for your opening speech. Next up, ladies and gentlemen, we'd like to focus your attention on the screen.
The world population is now 8 billion people, an unprecedented speed of industrial and urban development, and the COVID-19 pandemic propels a thirst for energy. The whole world is facing a wave of energy crises. The picture of the future will continue to look gloomy if we persist in running the world the old way. But currently, many countries have begun transitioning towards a greener, cleaner, and more sustainable future by implementing plans to shift towards renewable energy sources. How far have renewable energy technologies developed? How do we promote a quicker energy transition? What are some affordable and clean energy solutions? We will have these answers and more in today's panel session on the future of energy.
Ladies and gentlemen, next up, I'd like to give a few words on the Future of Energy chair and speakers and do an introduction. The chair for this panel is Professor Sir Richard Henry Friend, 2010 laureate of the Millennium Technology Prize in Physics for his work on plastic electronics, one of the world's most influential physicists. So Professor, I would like to invite you on stage to take your seat, please. And joining Professor Friend, we have the panel of scientists who are joining us both online as well as offline. Offline, we have Professor Tok Nguyen Nguyen, Director of the Center for Polymers and Organic Solids at the University of California, Santa Barbara, one of the top 1% most cited researchers in materials science. Professor? Next up, we have Professor Antonio Facchetti, co-founder and CTO at Flex Tetra Corporation. Professor? Professor Facchetti also holds the gold Giulio Natta Medal of the Italian Chemical Society for his work on electronic materials. Next up, we have Associate Professor Pham Hoang Leung, Hanoi University of Science and Technology, clean energy expert. And ladies and gentlemen, we also have two professors joining us online. Professor Gérard Mourou, 2018 Nobel Prize laureate in physics for the invention of pulse amplification, a technique used to create ultra-short pulse, very high-intensity laser pulses, one of the leading scientists in the electrical engineering and lasers in the world. And then we also have Professor Konstantin Novoselov, 2010 Nobel laureate in physics for his breakthrough experiment in the supermaterial of graphene, one of the world's most influential scientists and most cited scientists. Welcome, professors. And Professor Friend, I'll leave the stage to you.
I think we're going to have some slides. I'm going to do a short introduction, and yes, we have the opening slide. Well, it's a great privilege and pleasure to be here. It's very exciting for me to learn how progressive the grand plans in Vietnam are to be a leader in the transition in energy that not only must we do, but we can do. I'm going to start asking you to look at the first statement below Future of Energy. That is that we have to reduce carbon emissions net to zero by mid-century, by 2050. And if we do that, with luck, we will contain climate change to no more than 1.5 degrees beyond pre-industrial temperatures. I can say that, and no one from the audience has stood up in disgust to say that's not true. If any of us had said that 10 years ago, maybe a quarter of anyone of any particular audience would have said, that's crazy, we're all going to be poorer, and you can't prove we need to do it. Times have moved on. We now accept that the residual doubt is gone. That was very clear at the climate change conference in Glasgow in the United Kingdom in November last year. There have many disagreements about the individual contributions from individual nations, but no one doubts we have to do it. So that is a very somber context for the conversations we have to have. But the good news is that options now available are far more promising than we thought they would be even a short time ago. We're going to explore in this symposium where technology, and new technology in particular, can play its role in making new energy affordable. Unless zero carbon energy is affordable, it won't happen. No government is going to make its people poorer lightly. If it is good economic sense to transition to zero carbon, then that's so much easier. So we're going to talk about principally energy generation, but also storage and efficient use of energy. And we're going to talk about the infrastructure we need to do that, which is essentially electrification. But that point that technologies must be scalable, affordable, and accessible underpins what we need for progress. Can I have the next slide? Thank you. So this is a slide of no particular significance other than that it sets out the trends which are indisputable. you see over the past decade, these are actually quite conservative estimates of the cost of commercially generated electricity. Back in 2010, the cheapest form of fuel, or the most available forms of fuel for electricity, were coal and nuclear, and a small amount of onshore wind. If we fast forward a decade, and this is now 3 years out of date, the cost of solar has fallen quite spectacularly, much faster than even the optimists thought it would do. So it's now down to being in the right parts of the world, the cheapest form of new installed electricity generation. Why that is very interesting. It is in part due to improved technology. Very interestingly, it's also due to scale of industrialization and deployment, and a much more sophisticated financial structure that has now reduced the perceived risk in solar installation from high to low. So it is now low interest rate patient investment from pension funds that will fund solar. A decade ago, they would not. Now, in detail, we can argue about the numbers, and I will. I didn't generate this slide, so I can be critical of it. If I look at the number for offshore wind, it comes out at $115 per megawatt hour. Well, yesterday, in the United Kingdom, there was an auction for offshore wind, and we sold an extra 25 gigawatts, which is about 40% of UK electricity consumption. It's a huge amount. The price that the government guarantees to buy that electricity at is not $115, it's $60. It's half. The cost of offshore wind in the shallow seas around the United Kingdom has fallen dramatically because of cost of finance and because of improved operation. The operational risk has been massively reduced, and it is now seen to be reliable. This is all completely unexpected. So those are my words of introduction. We're now going to have a conversation amongst our physically present and online participants, where what we're going to do is explore what lies behind, where the science that lies behind these changes may be able to take us. So I think I'm going to, I'm going to turn to our panelists. And we have a number of questions that have been generated locally, where we've picked up some of the interests and concerns that are representative of people in Vietnam, but they're very representative of the global view. And the first question, which I'm going to turn to Professor Moreau to address, is the following question. 30 years ago, it was predicted that the world would have an energy crisis due to limitation of oil production. Today, people say that energy demand in the next 20 or 30 years will double and essentially will run out of fossil fuels. Is that true? Can we be optimistic about alternative energy sources? So, Professor Moreau, I'd perhaps ask you just to briefly introduce yourself and your interests in this, in the field of energy.
Okay, well, it's a real pleasure to be with you In fact, I'm talking to you from home hospital here because yesterday I was tested positive for COVID-19. Okay, and I'm really pleased to be able really to trying to convey my passion for what we could really be something which could really solve, at least greatly solve, this energy crisis. Of course, we know that over the past maybe 10 years, we were relying enormously on atomic energy, okay? Especially France, sorry, you know, 75% of its electricity is coming from nuclear energy. And, but we have seen some of the problems that with Chernobyl, with Fukushima, etc. I mean, we had problems with atomic energy. But atomic energy is something which would be very, very important. And we have to take that very, very seriously. Right now, atomic energy relied on uranium cycle, okay? And so it had problems. We had problems with waste, short or long-lived waste, and so on. And what we are proposing, and we are a number of doing that, we are proposing now to really trying to go, instead of uranium cycle, to go to thorium cycle. And the thorium has the advantage, a number of enormous advantages. First of all, it is extremely abundant. If you consider, for instance, that the coal, the energy that we have in terms of coal, is expressed in zeta joule, 10 to the 21 joules. Carbon is 1 zeta joule. Uranium is 5 zeta joule. And thorium is 1 million zeta joule. Okay. On top of that, thorium really produce much less nuclear waste, much less by a factor of 10,000. And also, the life of the toxic material, I mean, the toxicity lifetimes is very, very short compared to uranium. So I think we can see, as Professor Friend said, there is some new opportunities, and with nuclear energy, but we were not so much considering before. But we are clearly, I'm very hopeful that we will be able really to use nuclear energy and to produce very abundant and clean energy. It is predicted that for thorium, for instance, we could feed 10 billion people, you know, for about 10 or 20,000 years. Okay, so for me, I think we should explore everything in terms of energy. Everything renewable is fair game for me, but there's one that we should really take very, very seriously, is nuclear energy, and especially trying to use thorium cycle. So I'm going to stop here for the time being. And if I have questions, I will answer this question later on.
Thank you very much, Professor Moreau. Can I ask you perhaps the next question, which is the opportunity in nuclear is clearly very important, and the way you highlight thorium just gives us a sense that science is never exhausted. There are always things that we have neglected or overlooked, and the vision you set out is very attractive. But the next question is, how do we get to scale quickly enough?
Well, I think it could be scaled quickly. If you consider, for instance, that the concept of thorium reactors has already been demonstrated about 40 years ago or 50 years ago. It's a kind of old concept. And also, we know that China in 2030 will come up with its first thorium reactor. So I think it's, for me, it shows that, you know, we are in a very good way to
thank you.
To integrate this thorium into the mix of what we need in terms of energy. Yeah.
So it is changing, if you like, international appetite to re-engineer energy, that presents new opportunities to reinvigorate investment in nuclear, and particularly nuclear that, in the case of thorium, offers less waste and a more abundant fuel supply, but it does need new technology, new development.
No, it doesn't need. I mean, certainly some improvement must be achieved. And what I'm proposing, for instance, is to use ultra short pulse lasers to are producing the proton that we need, you know, to make thorium usable.
Thank you very much. I'm going to turn now to Professor Gwyn, and the broad question is, we have some options which are, in principle, very attractive, but do we know that they're the right options? If we press forward with renewable clean energy that produces zero emissions, are we going in the right direction? Are there examples of actions taken in other nations that show how things can go?
So, with answer to that question, I think it's very possible, and we go in on the right direction. And so there are numbers of examples of countries around the world that have successfully gone into energy transition. And for example, Sweden, Norway, Denmark, and those are the top few nations: United Kingdom, Austria, Switzerland, Finland, Australia, New Zealand. And so another example for Costa Rica and also Uruguay. So nearly 100% of their energy production come from renewable sources. And so when we just discussed by Professor Muru and also Professor Friend that there are many different renewable energy sources available. And so there are more than one option, and it really depends on which country and geography. For example, Uruguay and Costa Rica, due to their geography, that they strongly rely on solar, wind, hydro power, geothermal, for example. And beside the energy sources, another thing that you have to take into account the smart grid and clean transportation, and also, you know, the building design. And so the next, usually people wonder how those countries really achieve such, you know, successful. And I think the key is really lie on the diversify of energy mix, also lower the energy production costs, and clear decision making, also supportive regulatory environment, and strong partnership between public and private sector, and also people lifestyle and also behavior, right? And so that's my opinion. Yeah.
I mean, looking at the technologies that you know well, would you say a bit more about, or say something about, you know, where you see the future from your scientific perspective?
So my research really on the organic solar cells. So we know solar cell, which is the one you see around the world, majority they use silicon technology. And so the organic solar cell, the advantage is that have the semi-transparent and can be made flexible and lightweight. So their application I see that can be on building integration, glass window, and so for example, 40% of energy production or use in the world go into building, right? And you need to run elevator and lightings and air conditioning and heating. So this is the area I see that organic solar cell can have also very useful if you coat all the glass building with this type of technology. Yeah.
So you're pointing out that solar cell technology is, we think of it as just silicon, but there are new materials that may complement silicon, may allow solar to be deployed where you wouldn't use silicon, which is very exciting. I'm jumping around a bit. Let me turn back to the list of nations that have made some big progresses. Some of them have some natural advantages, but it is good to have a small population, and it is good to have mountains so that you have some hydro. So Sweden and Norway have a lot of hydroelectricity, which is both useful for generation, but it also helps with storage, I think. And Denmark has lots of shallow sea. Are they fair models, or how well does that generalize to other nations with not so many natural resources?
So very good point, Richard. That should highlight the important point that we have many different options. So one, we need to take into account the population and also the geography of the country. We cannot just take exactly that model and put in another country that it will work. To give an example from Vietnam, so we can take into we look at our geography. We can look at we have the coastline from north to south, and in the middle part of Vietnam, we also are very sunny, right? And we have strong wind from the coastline. So we have to take into advantage of each country and design the model that works best for that country.
I think that message that there may be globally a set of technologies which we can turn to, but locally we need to adjust to make the right local choices.
Yes, absolutely.
So still on the subject of solar, I'm going to turn to Professor Fascetti. And the question really is, what is the future of solar? Is silicon as good as we need or as good as we can have? Or will we be able to go much further? And maybe just briefly introduce your own research interests.
Thank you, Professor Friend. My research interests are mostly in semiconductors, organic semiconductors, not too much for the production of energy, but for producing circuits to drive display sensors in an unconventional way. So what I've been mostly studying is developing this new material that can be printed or can be deposited from solution at low temperature instead of to use vapor deposition and photolithography, which are very energy intensive. Going back to your question, I'm very excited about solar mainly for three reasons. One reason is you show the reduction in the cost of producing the electricity by different technologies, and you saw a great reduction for solar. And this is expected to continue to reduce considerably. By 2030, it is expected a reduction of 20%, and by 2050, there's different models, but there's still a considerable reduction between 30 and 50%. And this is different compared to other renewable. They are expected to reduce, especially offshore wind, but for other renewable energy like hydro, we don't expect a reduction. Also for nuclear, we don't expect a considerable reduction if, consider it as one of the renewable. Onshore also, it's going to be difficult to further reduce the cost because of the critical material needed to produce some of these components. So I'm very excited about solar as a future energy source because of the continual reduction of the cost. But there's also two other important aspects which I'm very excited. One is solar is unique that can be going from very large solar farm to your home. So the broad applicability, the applicability can be so broad, and this can greatly reduce the cost moving forward. And the third one is what Professor Piano was talking about. There is different technology in the solar, not only silicon, but there is organic. And now there is studies combining silicon with other materials in which the efficiency can be enhanced dramatically. And that can contribute to the reduction of the cost per kilowatt hour. So I'm quite excited about solar.
Okay, well, Professor Facchetti, thank you. I think you're a pessimist.
I am. I used to work in solar organic PV, but now I'm not. I'm not really
let me explain why. You said maybe a 30 to 50% cost reduction by 2050. I was looking at a very interesting study from the University of Oxford Energy Policy or Group, and they've done some modeling as to how costs fall as the market penetration increases. It's something that is called Wright's law. Now, they don't know what the technology will be. They just look at historical developments of how, when something is deployed at larger scale, the cost falls. And they think the cost will fall by 500% by 2050, down to 1 US cent per kilowatt hour.
This is even more exciting.
I'm not saying it's true, but every time ordinary conservative people make projections for where solar will go, the cost has come down, and everyone presumes it's now flat. And the question we have to ask is, can it carry on going down? And I'm challenging you to be a more optimistic.
I am very optimistic. Also, looking at the way you produce the key material, silicon.
Yeah.
And I think that is, if you use solar to produce silicon, then this is an opportunity to reduce the cost per kilowatt hour. And if you combine silicon with other materials, so when you go from 20% to 30% efficiency, then everything gets up. So I'm very optimistic.
Okay, well, I just wanted to make our discussion as positive as possible. But let me turn. We've talked a lot about generation, perhaps more around solar, but I did mention also how wind has improved, and we've heard from Professor Moreau as to where there are great opportunities to rethink nuclear. But the the two other pillars of the energy economy are storage and use. And I want to turn to Professor Novoselov to give a perspective on storage, in particular how batteries are changing and how that depends on the discovery and engineering of new materials.
Morning. I'm terribly sorry to join you online. Please let me know if my connection breaks down. And Professor Fran, you are absolutely right that we have two pillars. One is the alternative production methods for our energy, and another one is more efficient consumption. But storage is extremely important, of course, and we already spoke that our grids have to be balanced, and that's why we cannot afford just blindly switch from gas and coal to renewable like wind and solar. We need to think about proper storage. It's either hydropower storage, for example. I think we do have to stick with nuclear for a foreseeable future, or maybe forever as the constant energy supply. But you are absolutely right that there is a third pillar of more efficient use and more efficient storage. And I think what we also need to consider is another idea of I would like to call it produce where you use it. Just let me give you an example here. Sorry, can I inquire? Can you hear me well, or do I break badly?
You're coming across just about okay. So please
Richard?
carry on. Yes, we're good.
Okay, great. All right. So let me give you an example. So another topic for today's discussion is AI. We have to generate a lot of data, of course, for AI, and usually we use local sensors for that. So these days we're combining AI with the Internet of Things technology. So we're talking about AIoT. And if you think how many devices we use, portable devices we use, and how many batteries do we have to utilize for that? So I was quite shocked and surprised to see that the carbon footprint for the production of those local sensors and portable batteries these days is larger than the aviation footprint. So at the same time, it would be possible to generate energy locally, especially for those small things, low power consumption things like sensors, like remote controls, and so on. So this area of local power generation, ambient energy collection, I think will be another pillar for energy usage. Imagine if we can scrap all the aviation carbon footprint altogether. That would be a big deal. So tribology, piezo, thermal power. I think the research which President Gian mentioned of the organic solar cells, if you were able to produce even low efficient but cheap, low cost paints which are semi-transparent, which are able to collect ambient light and turn it into electricity. That would be that will have a great impact of our efficient energy usage. So for me, the new material, the new nanostructures, composite materials which are capable of collecting ambient energy will be another play another big impact in the overall energy cycle.
So, thank you very much. To put you on the spot, new materials play a big role, and your graphene, which of course it is you that brought graphene to everyone's attention. Graphene seems to be playing a big role in perhaps the highest performance batteries. Could you say a little bit about where that may go?
That's very much true, and we use these days we use graphene in mass for new batteries and supercapacitors. So as you can imagine, modern batteries is the recipe for modern batteries are extremely complex. We use hundreds, if not millions, of tons of graphene, as well as carbon nanotubes, nanosilicon, other materials for the for modern recipes, and it's and we keep fighting for every percent of the efficiency of those batteries. But as I said, batteries is only part of the equation. Local generation of energies through thermal power, through tribology is, I think, will play an important role as well, and that's why other materials with more efficient figure of merit for thermal power will be of extreme importance for the future. So I don't think our research stops at graphene only. We're going towards to produce better solutions.
Thank you very much. I mean, I'm an optimist, and to me it seems that we look at one member of the periodic table, which is silicon, and we see how far that has gone. And we need to remember that we can do that with the rest of the periodic table, that there are, and Professor Novoselav, you've just explained how there are other energy conversion technologies, such as thermoelectrics or piezos, and that's going to require that reinvention of what we can do with new materials. But can I turn finally to Professor Luong to ask you to address first that third pillar, which is we've generated our clean electricity, we've stored it, and now how do we use it?
Thank you very much. Dear Dr. Eevee, the Deputy Minister of Ministry of Science and Technology, ladies and gentlemen, good morning. It's my pleasure to be here with you. Thank you very much, Vin Group, already having extended high invitations so that I'm able to be here. Come back to the question raised by Professor Franz. I would say that the energy transitions nowadays is a global trend, and Vietnam is not exceptional. And Vietnam government has already committed for the climate change mitigations. So the idea as to how to develop clean energy technology is very crucial and very relevant to our Vietnam current energy scenarios. I've been listening a lot about the experience from different panelists on the development, the disruptive technology ongoing worldwide, and Vietnam wants to develop, wants to apply that kind of technology to solve our problems. And talking about the electrifications, as you already mentioned that, okay, so far the national grid in Vietnam relies heavily on the fossil fuels based system like coal, oil, gas. But right now, with the challenge to move forward for the energy transition. Basically, we try to accommodate the increased shares of renewable energy technology into our grid. We have to think out first. We need to change structures. We need to think about the operation of the whole system. It's not easy to move from the coal-fired power plant or thermal plant into the renewable energy. So we need to combine with the energy technology, basically for the renewable energy technology, with the energy storage. That could be go along with. And another issue that we need to focus also on the energy efficiency methods. You also take into account to move forward for the energy transitions.
But when we talk about efficient energy use,
Yes.
We need perhaps to look at everywhere we use electricity, that there are some famous examples.
Right.
The Nobel Prize winning work on the development of LEDs for lighting
Yes.
has reduced energy consumption for lighting by a factor of 10.
Yes.
And that has happened, that has transitioned everywhere very quickly. Where else, maybe we can't get such a big improvement, where else should we be more careful as to how we use valuable electrical energy?
You may know that nowadays, with our modern system, we just move from the fossil fuel base into the system relies on, basically on the renewable energy technology. So sector coupling is very important. And it happened everywhere, not only for the production, but also for the end users, for example, in the buildings, or even in the transport, and even the chemical industries. So it happened everywhere, particularly for the buildings. Right now, you can get electricity directly from the rooftop solar, for example,
Yes.
and you can use it more efficiently compared to the other technology which are available.
I mean, we're very conscious for where, I mean, I come from a much colder country, and keeping warm in winter is very expensive. And we know actually that buildings, construction, still is way behind where it could be.
You may know that in Vietnam, building sector will be the very important, where energy is extensively used. There is a lot of chance to minimize the energy use in the building sectors.
Yeah.
So I think for the new energy technologies that could be very useful for the building. Talking about the demand response, for example, we can adjust the demand response of the buildings by using very modern technology through application of the AI or big data, for example. So going with the energy efficiency in combination with the AI, big data, that could be solved very quickly for that kind of things.
So if I can switch to another question to you, because it's very important to have a local perspective on what the options are. The energy transition is disruptive. It will remove certain sorts of jobs, but replace them with other jobs. Can we take a positive view? In Vietnam, there is local coal production, but to hit net zero, it is quite hard to burn coal unless there is very good carbon sequestration. But on the other hand, solar, wind presents new opportunities. Is there can we take a positive view about that future?
You're right saying that net zero emission is not easy. It's a really challenge. It's very ambitious for all of us.
Yes.
But I think I'm really positive in the sense that in the near future, due to the depletion of the fossil fuels, so we have to move forward from now, right now, to see other alternative sources of energy. So solar, wind, even biomass, geothermal, etc., should be playing very, crucial role for the development of Vietnam. Now, in order to develop renewable energy technology, we have a lot of lessons that we can create additional value for the local communities. Forever, if you want to apply solar thermal application, the local people can use solar thermal to create, to enhance the quality of their own product. That is the kind of thing that is very value. And we already talking about the different type of renewable energy technology to develop. We need to think about the supply chain. Whenever you develop renewable energy technology, you must create accordingly supply chain. So the supply chain should create additional labor, investment, and even employment for the local people.
I think that's a powerful point that is sometimes overlooked, that a common feature to renewable energy is that it is generated locally, so that does generate local jobs, and they could be good jobs. Yeah. And then it also means that the energy supply is secure.
Right. I think you're right saying that, but especially for the distributed system. So far, we have to rely on the long distance in the cable. But with the development of renewable energy technology, we can create the job for the distributed system, for the communities, for the rural area particularly. You're right.
I mean, to go back to things I'm familiar with in the United Kingdom, where the switch to offshore wind is going very quickly, that has in part been made possible because we have in the past produced a lot of offshore oil and gas, and the same skills to do the installation and maintenance of offshore rigs that was originally oil and gas is now wind turbines. So this
very good point you already raised. You may know that we are revising the VDP8 Vietnam Power Development Plan, in which the offshore wind share in energy mix will be increasing. That's very positive sign. And on the other side, the local Vietnam, for example, Vietnam Petro, they already have some experience in developing of oil and gas, explorations and production. So they have very easily to come into the supply chains. So that kind of thing could be developed. And depending on the budget allocation and also the other, mechanism to promote offshore wind technologies in Vietnam in the years to come.
But when I mention offshore wind, because I'm familiar with what is happening in the UK, but I think it generalizes that the change can bring good local employment.
Right. You're right saying that, because recently we already organized a workshop on offshore wind developments in Vietnam, which was hosted by the Central Economic Commissions, and I was invited as a moderator. We have a lot of experience from the Global Wind Energy Council. There are a lot of questions, there are a lot of opportunity and lessons learned from different countries, including UK, also Norway and others. I think that's a very good chance for us to develop.
Sure. But that would be true for solar, it would be true for nuclear. There are just many employment options. Thank you, my fellow panel members. I would like now to turn to from the audience. I'm not. Do we have our MC to come and? I can pick up questions.
Yes, sir. We will continue the Q&A section, but I think before the Q&A section, we will have a short clip that's going to be played.
This could soon be the future of humankind. You can have pure air to breathe, and children can entirely connect to nature. This is the benefit of humans cutting down on air pollutant emissions and adapting innovative energy technologies. Ecosystems that we lost decades and centuries ago, being reborn. Making our oceans healthy again. Our land is being restored, strongly nourishing the resources we require as humans. Let's imagine houses. Factories in your neighborhood can also generate their own energy. They will even go as far as only using energy when absolutely necessary. And vehicles powered with clean energy will take you anywhere you want to go. This is the result of a mind shift in creating new renewable energy sources, greener and cleaner. together with a more efficient and fair energy consumption mindset for all mankind. We will discuss the next story of Energy Future and our efforts to cut down emissions with our experts right now.
Thank you, Professor Friend, and thank you, professors. It's now time for us to proceed to the Q&A section. I'm very, very happy to announce that we'll have opportunities for the offline audience as well as the online audience to be asking questions. And so how do you ask questions? As an offline audience, you raise your hand and we will have mics to come to you, and then we will have the questions. So does anybody want to ask a couple of questions? I think I see some hands right there. I think the mic should go to, the hand that stood up first.
My name is Kim from Bean Group. I want to talk about, I want to think about together about the Eevee infrastructure trend. So in recent years, the commercialization of electric vehicles is accelerating. At the same time, there's a big movement to stop developing conventional gasoline engine vehicles. However, for the popularization of electric vehicle, a plan for the production of electric energy that can smoothly support the operation of EVs is required. I guess that developed countries will make good use of nuclear power and renewable energy, but I'm really concerned about whether the whole world cooperation system will be able to keep pace with this trend. Are there any good ideas to support not only developed countries, but also whole world for this purpose?
If I can rephrase it, that we can quickly switch to electric vehicles, but it's going to require more electricity, and where does that come from? Can I turn to maybe Professor Wang? Can I ask you to give a sort of local view on that?
So thank you for your kind questions. Right now, we are not talking about the energy production, basically for the electricity generations, based upon the renewable energy sources, and how we can use this in the new futures. Okay. So I think that we already discussed at length how to generate with a higher efficiency, but how to use it, and how it should be cost effectiveness, and how it should be affordable for the local people. So I think it depends on so many things. The technology development is one issue. The other thing regarding the scope of the technology to be developed. And the last one, the others appropriate mechanism to be developed. So I think it's one of the issues. Renewable, as I already mentioned earlier, that it's not easy to develop. It depends on the country specifics. For the developed countries, it should be fine. But for the developing country or new emerging economies like Vietnam, it takes a little bit time to prepare for the other things. We have to think about the market. When we are not seeing from the production side. We need to think the whole chain, how we can digest electricity if it is a surplus compared to our current national grid.
But we will need a larger electricity generation capacity if we switch to electrical vehicles. One of the lingering questions is, are we sure this is the right way to go?
I think that is the tendency of global tendency. And I think that, I think you already have some information from the VinFast, okay, Vin Group. They already try to develop some sort of Eevee for the new futures. So it's a trend globally. But in Vietnam, it also depends on the other thing we have to take into account regarding the market for that. Infrastructure to develop, just in case we can accommodate the increased sales of the Eevee in the transport means.
Great. Can we perhaps get another question?
Good morning, panel. This is Rohit Verma from Win University. I have a question related to the waste generated in the new sources of energy. Please allow me to elaborate. If we think about electric vehicles, we need new batteries. These batteries need to be produced. In the production process, lots of waste gets generated. And at some point in time, these batteries will have to be disposed of. And they will have many toxic chemicals and other materials. This is my understanding as a layperson. Similarly, with solar panels, the production process is quite intense, quite dangerous, and also creates lots of waste. So yes, I do agree that at the point of consumption, it is clean green energy, but the point of production, it can be quite hazardous for the planet for the long term. So I would like to ask the panel's opinion about the waste generated in the future of energy as you have described. Thank you very much.
So, turning to the panel, any views on what we should do with batteries? Professor Novoselov, do you have a view about the battery world?
I think this is a very crucial question moving forward. I was very enthusiastic about renewable, and I am. As a matter of fact, I'm very convinced we can meet the energy, electricity demand purely by sustainable energy resources. That I'm very convinced. But the key problem remains the production of the technology. And this goes back to chemistry, and I'm a chemist. Unfortunately, nature, as a matter of fact, created most of the key minerals that are used to produce lithium, for example, is lithium carbonate, or limestone that is used to produce cement. And so all of these elements contains carbons. And we are very unlucky, as a matter of fact, we have this. So we need to find, to answer partially the question is, we need to find, not only look at the production of the electricity, but how we produce these chemicals in a way that does not create waste, which can be carbon dioxide, and can be done by chemical processes which don't use carbon as a key element. And I think this is a very important point.
Professor Long.
Yeah, may I add on very relevant question regarding the renewable energy technology, including not only for the batteries. We think about the end of life solar photovoltaic panel, and even for the wind turbines. After the time of using, it must be demolished. How we can manage it? So whenever you talk about the technology development, we should see the life cycle assessment of the whole thing. That could be very crucial for the local people if they want to develop.
So what is perhaps different this time, particularly with batteries, is we can see it coming. So rather than creating the waste and then thinking about it, we actually have time to prepare for how we recycle a battery in 5 or 10 years' time as the production ramps up. So there is certainly some discussion globally about just that we should be planning for end of life at birth. And we can do a better job than we have in the past. I'm being eternally optimistic today, but I hope not too simplistic. How much time do we want to run for? I think we're good until a few more minutes. Can we have another question from the floor?
Thank you very much for this very informative panel session. My name is Vicky, also from Vinh University. I want to ask a question about something that relates very importantly to the future of energy, which is a concept about energy poverty. So we're talking about clean energy and the use of future energy right now, but it's also true that currently there are around over 1 billion people who do not have access to energy, and as we progress into the future, the world is expected to have a population boom, and it's precisely in some of these countries that don't have access to energy now, such as sub-Saharan Africa, that they're expected to have one of the biggest population boom. So they will have lots of more need for energy, but currently they also don't have energy at all. And it's going to be very hard for them to build the facilities to, even for fossil fuels. So it's going to be much harder for them to build the high technology for renewable energy. And I'm just wondering that how can we, first of all, help them build that infrastructure and transition out of energy poverty, but also I'm curious that if suddenly all these people who don't have energy suddenly do have energy, will that create a problem in moving towards net zero because that's going to emit more carbon emissions?
So that question about energy poverty is such a good question, and it challenges a lot of our thinking about our need to think globally. I have been involved actually in a small startup company back home where we are selling or helping to sell a very affordable solar light system where we use a solar panel to collect electricity in the day, a lithium-ion battery to store that energy, and then a very efficient LED light to provide lighting in the evening. And that is less than half the cost of a fossil fuel form of light, which is burning kerosene. And right the way across Africa, there's a very fast switchover to off-grid solar generation. And the challenge about fuel poverty is that where people are far away from the grid, energy is very expensive. And actually, if we can deploy fairly some of the technologies that we may have generated for smartphones and our first world gadgets can be very well deployed to address poverty. But I hope that doesn't come across as a sop to a real problem. But maybe, can I turn to other panelists to add to that?
So yeah, I would like to add into the point Richard made, and also earlier Professor Leung mentioned, we have to take into account the local area and see what type of energy production is more affordable. And I think that I agree that there are still over 100 million of people on the globe that don't have access to electricity. And so for a number of them from a developing country, and I think, for example, in Africa, and there are a project they call Lighting Africa, right? For those places, even though some remote villages in Vietnam, in the highland area, still have no electricity. And for those areas, I think renewable source, like silicon solar module, will be more affordable and easier to integrate into their daily life. And for those, I think it's more a better solution. Yeah.
I just follow up the feedback from Professor Fred and also from Professor Tu Quyên that for the distributed areas, it's very crucial to develop renewable energy to supply in situ for the local communities. But the main challenge is how to educate the people to master the technology. That is another issue. We are talking about the technology development, we have to take into account how we can do capacity building for such areas so that it should be sustainable.
I think to go back to this really important question about energy poverty, one of the positive messages that has emerged in Africa is that when there is solar lighting, the light, if you like, you've prepaid, so you use it. And school kids are now able to do homework because in rural communities, school kids work in the fields when there is daylight and then it's dark. And in the past, their education stopped. And now they can do their homework with that LED light. And that, I use that as a sort of small example of how central energy is to providing opportunities. It extends into healthcare, that we have to have energy to start with.
Professors, thank you for those answers, and thank you, audiences, for the questions. We do have a number of questions online as well, so if it's okay, I would love to be able to address some of our online questions. To the audiences, we have quite a number of questions coming in. We don't have time to answer all questions today, but we hope that we will continue to have this ongoing discussion and communication even after the event has ended. So this is the question that's coming in from online that we've chosen to ask our panelists today. So the question is, 10 years ago, people said that solar panels were too expensive, but now we use them everywhere. So the question is it the same for hydrogen and for ion batteries? Panelists, what do you think?
Can I turn to our materials experts on the stage?
Well, for solar, definitely. For hydrogen, it really depends how it's going to be produced and distributed. That is the key element. Right now, there is not an infrastructure for hydrogen, and it's a key issue. But for example, there is an infrastructure for ammonia, and you can actually use a sort of ammonia as a bus of hydrogen, so you can produce it. For example, there is a project in Australia where ammonia is widely produced using conventional fossil fuel chemistries, and then it's distributed throughout Southeast Asia. And the idea instead is to use this infrastructure to harvest ammonia and ship it and then convert it the way ammonia is produced from hydrogen, okay? So you take hydrogen, you produce ammonia, you ship it, and there is already the infrastructure, and then you convert it back to hydrogen. And this is something that can be done using existing infrastructure. So this is an example where hydrogen, which is the final goal, can use an intermediate infrastructure for its use and at a reasonable cost and technologically viable.
I just want to add a very small comment to that. As we advance in science and technology, and my answer to that question, yes, it's possible. So everything is possible. It may not be a direct route there, but we can combine with all the technology already exists that allow us to produce it and storage it or transport it at low cost. Yeah, it's possible.
Let me just add a brief remark. I think when electricity becomes very cheap and when there is excess generation from renewables, the cost can fall close to zero. It opens up so many possibilities as to what you will do with it. And hydrogen as the start of a chemical chain, if it's very cheap, it's very attractive.
Wonderful, thank you, professors. We do have one more question. I think we have room for one more question, and I think that's an offline question. I believe that our guest is really looking forward to ask the question.
Thank you very much, panelists, for a very interesting discussion. I am Chang Ngọc from PECC2, and so now we are in energy transition, and it's motivating many innovative, disruptive technology. And we have seen that in the past that the innovative and disruptive technology can lead to establishment of new industry as well as many startups in the ecosystem. So I would like to ask what kind of the disruptive technology is in the energy industry. And by that perspective, how optimistic can we be about the future energy? Thank you.
So that's a great question. If I turn to the panel, both online and here, any crazy ideas?
Well, I'm not sure about the energy production. We discussed many different types. But in terms of, I can focus on the energy efficient use of energy. For example, we continue to have construction, new houses, new building. Can we make smart building or green building where we consume very little energy, or even better, we have a building that you can generate enough energy to operate the building, and maybe even extra to feed back to the grid, right? So that could be, to me, that disrupting technology for the new energy efficiently. Yeah.
I'm just going to throw something out which might seem a little bit off the main thrust, but we all have smartphones. The underlying silicon technology is running at something like 100,000 times less efficiently than our brains. The human brain runs at about 20 watts. To simulate it in some measure takes hundreds of kilowatts of silicon processing power. And actually a lot of innovation is going to come from that world of IT. And I'm an optimist that that will spill over. I mean, so far we have had LEDs and solar cells and lithium-ion batteries that have come from that industry. And I would keep looking there because there's so much headroom.
All right, professors. I think, as we wrap up our panel, the first panel of today, what are some of your final words to our audiences, both online and offline?
Could we have the first slide up again, which was a sort of set of headings, which will refresh the audience. Well, I can speak to it anyway. And I want to look at the bottom two rows, electrification, and we need affordability. What this conversation, I hope, has illustrated is that we can have disagreements because scientists always disagree with one another. That's how science happens. That does not mean we don't know what to do. And common to everything we've discussed this morning is electrification. It is beyond doubt that the future of energy is electric. So there is no reason not to do things that advance that direction. On the other hand, we can have lots of disagreements as to whether the generation will be from thorium reactors or cheaper solar cells. That doesn't matter. We don't have to wait to resolve that to be able to proceed with electrification. And I think the fact that we know that now is very positive. And then turning to the bottom row, we have to get to scale. We can only get to scale if it's economically attractive. We need governments to provide the right nudges to check that the incentives are well aligned and some level of incentive, say, to tip towards offshore wind in the case of the UK has worked very well. And we need to make the private sector see it as an attractive opportunity. And we're seeing that with these spectacularly ambitious plans for electric vehicles in Vietnam. And we need that at scale. But we have options. It's very exciting and very positive.
Wonderful.
Thank you.
Thank you very much. Thank you. Thank you, distinguished guests. Thank you, Professor Sir Richard Henry Friend, the chair of our panel today. Thank you, professors on the panel, Professor To Quynh Nguyen, Professor Antonio Facchetti, Associate Professor Phạm Hoàng Lương online, Professor Konstantin Novosilov, as well as Professor Gerard Mourou. Thank you very, very much. And ladies and gentlemen, we still have 2 more panels happening today. And to remind you, Vin Future Prize honors science and technology advancements that service humanity. And for the second session today, the future of artificial intelligence, we will begin at 11 a.m. sharp. So see you back here at around 10:50 a.m. Enjoy your break, and thank you very much, professors. Thank you.